because I gotta get myself a GPS device and I gotta get two readings, right, between that point where the thread starts and where the thread ends. And I gotta get the readings off the GPS devices. Then there's a website, Gary, where I can put in those GPS coordinates and it'll tell me the distance between those 2 points in space. So I gotta get my own GPS and get my own readings for that. And I'd be the first person to say that I've used a GPS device, okay? I've gotten those two different recordings. I put them into a website to get the meters and they match up. And that's because I also got to be able to explain Einstein's general relativity, where a satellite and time and gravitational time dilations. Then I got to link that to what goes on at the French Institute of Weights and Measures. So the point is that I am 325.45 meters away from CERN, which is the destination point. And then I gotta connect that point to the line. I just defined a line. So in the future, when the general artificial intelligence is self-aware, what it's going to do, all that data from CERN for the Large Hadron Collider, all that data is on file. That general artificial intelligence will be able to put that whole picture together. Every bit of data from CERN one day will be ran as a simulation of every single billion and billion events that they had. Like I'm just seeing how a supercomputer that's self-aware, that almost has quantum computation, how when it gets so addicted to information technology and what's available on the net, that general AI is going to get all that data and very, very quickly assemble it to how it was, and it's going to recreate a three-dimensional picture, a movie of all those crashes, and it's going to, this is what they're doing at CERN in terms of assimilating a fine point in space. Because what I'm doing in my flat, Gary, I'm trying to use available technology and define points in my flat right down to the nearest meter, but at the LHC, they're doing that down to the Planck scale, where mathematics almost becomes unresolvable. Yeah. Because the blurriness of quantum mechanics is like, it all relates to perception and consciousness, and how consciousness works is ultimately what they're doing at the LHC and defining the Higgs boson and those particle interactions. That is the physical universe looking for a point, a particle. It's a mathematical picture, but what the AI would be doing when it's trying to become self-aware is trying to figure out that it exists and make all those connections. So I was just thinking about the future of artificial general intelligence and that huge database, which is the biggest database in the world. Because right, from CERN, that's where the internet evolved from. I believe the algos used in studying black hole research is the algos for data compression for Wi-Fi. Like, right now, my computers are working because of, CERN, basically, for the Wi-Fi algorithms. Do you know what the algorithm for data compression is for Wi-Fi signatures? Do you know what the algorithm is like for data compression for Wi-Fi? Do you know how the digital data gets, because it all comes down to digital, right? So in my flat, okay, I got three radios going. One is computer. In the middle of my flat, I got to get my torch. In the middle of my flat is my DAB, right? And at the end of the hallway, the mic got to pick it up. I have my FM. So that's three transmissions to get to this point, okay? They're coming by different routes. But the DAB is a digital audio broadcast, but the signal, okay, is slower because to get from FM to DAB, there's a computer that got to run it to a digital signal and then shift it further back in time because of the delay. It's going to be my computer, because the signal goes from the studio to an internet server to my internet provider, my local internet, the network, and then it comes to me by Wi-Fi. So I've just explained to you the three types of delays. So again, we're defining, right? We're defining another line. It's three possible paths. It's between me and Pete Tong's voice, his mouth at the mic at BBC Radio 1. So I had that done on purpose. Like, I've got my radio set up like that on purpose because it gets me thinking about space and time. And when you start thinking about space and time, you start to see how how the 300 atomic clocks around the world, they get their signals averaged because at different altitudes those atomic clocks run at different rates, because time is different in different gravitational potentials, Gary. So the reason why they got to average out all the atomic clocks is because they need to know exact time to the UTC second. And a second is defined as like 6,192,000,000 vibrations of a cesium-133 like outer loose electron. Like that's the current methodology for atomic timekeeping. But that relates to other parts of particle physics, like stuff that I have to explain to you. But I can explain how a lot of it gets linked to explain why in my flat the signals arrived in, but I don't have a GPS to record and add it all up, but it should all add up so we could track the satellites that give us our GPS signal, and we can see how time is running slower in outer space. Time slows down. Did you know that? Oh yeah. So time, like when you fall into a black hole, you know that time comes to a standstill, right? That's the idea. So that's high gravity. So time. Oh no. Time. I'm getting the size of the equation mixed up. You know. Yeah. So in high gravity, time comes to a stop. It slows down. But up in altitude, time is going at a different rate. So if we didn't know that, if Einstein wasn't correct in his field equations, we wouldn't know how much to fudge the signals by so we can get an accurate GPS reading. Yeah. Anyway, so that little string is symbolic of what went on at CERN and the part of the beam pipe. And I made my own beam pipe in my flat because I'm daring. My question to an AI is, can you recreate all that information into a movie of the impact point? Just like fireworks, so the AI could see literally quadrillions and quadrillions of events, because they got a lot of events recorded. Do you know how many exactly? Well, I can tell you. I can tell you all the facts on it. It's astronomical. That's a lot of frames per second.
No one can beat my roast potatoes. Alright, last track. Pick an artist.
Okay, anyway. That's what I called to explain to you.